A bullet leaves a rifle with a muzzle velocity of 521 meters per second. While accelerating through the barrel of the rifle, the bullet moves a distance of 0.840 meters. Determine the acceleration of the bullet, and how much time does it take for it to accelerate to this speed. Well, first thing to do is let's draw a diagram of what's going on here and some things that we know about the bullet. Like, for example, we know that the displacement in this direction equals displacement in the x equals 0.840 meters. And we know that the bullet, when it leaves the barrel, actually, we don't know anything about the bullet leaving the barrel, but we know that velocity initial equals 0 meters per second. We know the amount of, we do know velocity final equals 521 meters per second. So if that's a given, if that's given to us, we can go velocity initial equals 0 meters per second. We know that velocity final equals 521 meters per second. And we know that displacement in the x equals 0.840 meters. Now the problem is the question asks for two different things, so I'm going to divide my substitute and solve up into two parts. The first thing it wants to know is what is the acceleration. So our unknown over here is acceleration in the x equals question mark meters per second squared. The other question it asks is what is the time. So my unknown here is time equals question mark, and in this case it's going to be seconds. The equation for the first part is going to be the velocity final squared minus velocity initial squared equals 2 times acceleration times displacement. So now if I replace numbers for letters, velocity final squared is 521 squared minus 0 squared equals 2 times the acceleration, in this case in the x-axis, times the displacement, which is 0.840. Well, any 0 multiplied by itself blows up, and when I do the math, I find that 521 squared is 271,441, and that equals 1.68 a squared. I'm sorry, a in the x-axis. In order to get a all by itself on the right hand side, I'm going to divide by 1.68, and these things cancel. That's the reason I do it. But whatever I do to the right, I also have to do the left as well. So I'm going to divide by 1.68. And when I do the math, I get acceleration in the x equals 161,572.02 meters per second squared. And then to apply significant figures, 0 never applies. There's 3 sig figs here. and there's 3 sig figs here. So 3 significant figures later. Now I got to be kind of careful with this because it's pretty obvious that the 1 and the 6 and the 2 are significant, but then I need to include zeros to get those numbers in the correct place. They're not significant, but they're important. The second part of the question asks for time, and so therefore we use a different equation. And in this case, I'm going to use velocity initial plus velocity final. That quantity divided by 2, that's average velocity, equals displacement divided by time. When I replace numbers for letters, my velocity initial is 0 plus 521. That whole quantity divided by 2, and that equals the displacement, which is 0.8440 divided by t. Now, adding 0 to any number, that just blows up. And that gives us 521 divided by 2 is 260.5. And that equals 0.840 divided by t. In order to get t out of the denominator, I'm going to multiply the right side and the left side by t. And the reason I do that is so that t cancels. And then I get 260.5 t equals 0.840. And to get t all by itself on the right hand side, I'm going to divide by 260.5 on both sides. And the reason I do that is to cancel the number associated with t. When I do that, t equals 0.0032245 seconds. And then when I apply significant figures, I get 0.00322 seconds.